Loop quantum cosmology does predict some interesting things. I don't think this will be by any means definitive, and if you want to know why I think that, I can maybe tell you later. This, by the way, at the bottom is a picture, probably not a familiar picture of the cosmic background radiation, but what we've got plotted here is the square of the temperature variation with something called angular scale. So imagine the universe as a sphere, and we're looking at different angles along that sphere. Now, these peaks that you can see, 3 of them, one tall one and then 2 of equal size, equal height, they're actually quite characteristic of the equations of hydrodynamics. And because the cosmic background radiation was formed 380,000 years after the Big Bang, it's left an imprint of what was going on in the universe at that time. And what these are sound waves bouncing back and forth in the early universe, acoustic waves. I like to think the universe was singing, or maybe screaming. I'll leave you to decide. But notice in this picture a difference. The standard model of Big Bang cosmology based on general relativity predicts a slightly different curve at high angular scale. Loop quantum cosmology predicts the lower curve, and as you can see, the error bars on the data, most recent data from the Planck satellite, don't allow us to be able to make a choice at this stage. But when, with future satellite missions, we have the equivalent of DNA fingerprinting at this high angular scale, who knows? My feeling is it won't be definitive because it will probably be easy to come up with a theory that will reproduce whatever experiment says. But hey. Finally, I've maybe painted a picture that Smolin and Ravelli, they're not only great scientific collaborators, they're also good friends. But don't take that to mean they agree on everything. In fact, I picked up a beautiful phrase, I think from Lee Smolin's wife, I think, Dina. If you both agreed about everything, then one of you would be redundant, which I think is a beautiful way. Maybe it's the way to understand a marriage. I've said this approach to quantum gravity means we lose time. It disappears from the equations. Now, Carlo Rovelli, again, you might be familiar already with his book, The Order of Time, has no problem with that. Einstein had no problem with that, by the way. One after another, the characteristic features of time have proved to be approximations, mistakes determined by our perspective, just like the flatness of the Earth or the revolving of the sun. The growth of our knowledge has led to the slow disintegration of our notion of time. But Smolin doesn't agree. He published a book a little while ago called Time Reborn. I no longer believe that time is unreal. In fact, I have swung to the opposite view. Not only is time real, but nothing we know or experience gets closer to the heart of nature than the reality of time. I believe that to make sense of the universe, we must embrace the reality of time in a new way. That comes with a fairly hefty trade-off, though, by the way, because if time is real, then space is an illusion. So just so you know. I'll leave you with a couple of quotes. You've probably got the idea that I'm a big fan of Einstein. Still one of my favorite Einstein quotes is this one: reality is an illusion, albeit a very persistent one. But maybe just a little better than that is the great science fiction writer, American science fiction writer Philip K. Dick, who once said, reality is that which, when you stop believing in it, doesn't go away.